are doing apps. So I'm going to cover history and development. Financial apps is going to be Dan. E-learning, Alex. Tim is going to handle audit apps, and the future of apps is going to be Chad. So what is a mobile application? A mobile application is a computer program designed to run on smartphones, tablet computers, as well as other mobile devices. With apps, you kind of have a chicken and egg situation. Are apps incredibly popular because people carry their smartphones on them all the time? Or are smartphones incredibly popular because they have apps on them? So here are a couple statistics regarding smartphone users. 40% say they'd rather give up coffee than give up their smartphone. 65% said they can't live without their phone. 15% said they'd go without sex, and 18% would give up. 18% said they'd give up bathing. So it really goes to show how addicted people are to smartphones and applications. This is a bit of a timeline with regards to how apps have progressed over time. We've got the upper level, which you can see is a little old and archaic, versus the lower level, which is the iPhones, Droids, and tablets. The upper left was the Scion handheld. It ran the Epoch operating system. It was in the 90s. It was 16-bit. It pretty much just handled word processing, database, spreadsheets, and diary. Then we have the Palm operating system, which was introduced touch, which we're all very familiar with today. It ran apps based on production from C++ as well as Linux. So those are productions that still kind of are used today in certain applications. And over here we've got Symbian, which grew out of the Epoch originally, and it was a joint venture between Scion, Ericsson, Motorola, and Nokia. And up until 2009, up to about 250 million devices were running these kind of applications. Kind of became it became very deceased because it had a lot of incompatibility issues, and it lacked open sourcing, which the newer models have. In 2007, the iPhone became available, and today, over 50 billion apps have been downloaded. And as far as Droid, the Droid store opened in October 2008, excuse me, and 35 billion apps have been downloaded. So things have exponentially grown. They expect the numbers to continue to rise that way, and there's no end in sight, and they are incredibly popular. So, how do you go about creating an app? There are really two ways. You go to a mobile app developer, or you can do it yourself. With mobile app developers, you go to an individual or a company such as ZCO Corporation, Fueled, MentorMate. They charge over $150 an hour, can get very pricey very quickly. With regards to do-it-yourself apps, it's kind of like the IKEA of apps. Companies build the layout for it, and you put your own company's information on top of the app. Pictures, information, how you want the app to run, but the basic layout is there, and it's much more affordable. Companies such as Appy Pie do it for as little as $7 a month, and it progressively gets more expensive. AppMaker is $79, and they even have professional do-it-yourself apps, which has the basic layout, but major companies like the NFL, NBA, Universal, and even Cirque du Soleil do it, and they can cost upwards of $600 per month. So with the do-it-yourself apps, you can get very basic functioning, but you can also get highly professional functioning from those apps as well. And how do apps make money? So there are pretty much four basic models to it. There is the individual purchase, where they'll charge you 99 cents to buy the app. Then there's the freemium model, in which they'll give you the app for free, and then it's got in-app purchases, which could cost anywhere from $1 to $5, $10, anything like that. Obviously, there are advertisements anytime you open an app and you have to wait 5 or 10 seconds for something to come up. It's because a company's paying to have that on there, so advertisements. And as well as corporate acquisition. Recently, Facebook bought WhatsApp for $19 billion. The app itself isn't worth that much. It's the amount of subscribers that WhatsApp has. It's got 450 million subscribers, and Facebook wants access to those people, that information, and to them, that's incredibly valuable. Angry Birds turned down a $2 billion acquisition because they felt they were worth more than that. I don't see how shooting birds at walls is worth more than $2 billion, but that's their opinion. Next, I'm going to pass it off to Dan.
Okay, so financial apps were created, in essence, just to help people save their money and have their budgets and everything right on their phone. So this started with the software that's called Personal Financial Management, and it just helps users manage their money. And it was kind of created in 1983 with the founding of Intuit, who also creates the popular accounting software of Quicken and QuickBooks. And a recent study found that 19% of Americans are actually spending more money than they make, which is pretty surprising, and that just kind of shows how this software can be very helpful and useful to most Americans. The most prominent financial app is Mint, and it was recently acquired by Intuit for $170 million. And it was recently won a lot of awards, such as Best Finance App by the first annual App Awards, and it was listed in Time Magazine's 50 Best Apps. It's free on the iOS and Android, and currently has more than 10 million users. So a few things that Mint can do for you: you can enter in all your bank account balances and view them in real time, all on your phone. So if you use your debit card to purchase like a sandwich somewhere, it'll instantly update that for you on your app. And you can also add multiple credit card accounts. You can add your loan accounts, so you can keep track of your loan payments, and retirement accounts, so you can keep track of almost everything financially. But the thing is, it's a read-only service, so it doesn't infringe on e-banking or anything like that. You can only look at the balances. You can't actually transfer money or do anything with the money in the accounts. Another thing is you can set budgets for weekly periods and monthly periods for anything such as restaurant, groceries, coffee. And so it'll alert you right when you're reaching your budget, when you go over, or when you have a lot more money to spend in that budget. And it alerts you of when you have unusual activity on one of your accounts, which is pretty helpful. And also you can put in all the due dates for your bills. So it'll alert you, say, a few days in advance, so you never are behind on bills again, and you'll always be up to date on that. They also have helpful graphs. Just a lot of people like looking at their financials in graphs better than just charts of numbers. And this is actually, it's very helpful because it's similar to budgets. It shows you how much you're spending over time. It shows you certain trends of what you're spending more on and what you should cut back on. And it shows you how your spending's changing month to month. So the graphs are a very useful part of Mint. Another thing that's available on mint.com, because Mint originally was a website and then it turned into an app, it tracks your investments, and it can compare your portfolio to other market benchmarks and pretty much anyone you want. This isn't available on the app yet, but soon it likely will be. And also, after each month, it can personally recommend investments to you. So it's kind of taking away the need for a personal financial manager. These are similar other financial apps that weren't as inclusive as Mint, but have certain features that I found would be useful on Mint. One of them is the Smart Scan, which is on Expensify, and that actually you can just take a picture of your receipt and it scans it instantly into Mint or into Expensify and updates your bank account for what you use to pay for that. Budget has a currency conversion, so if you travel a lot, if you travel abroad a lot, it'll instantly convert all the currency into wherever you are, so you don't have to do that manually or calculate that. And Dollarbird has a feature called estimating, so if you're spending a lot during the first week of a month, it'll estimate how soon you'll go over your budget that you set for that month, and it'll tell you to slow down and what you should spend less money on. And so next, I believe it's Alex with e-learning.
Morning, guys. I will talk about e-learning. I will discuss some trends in e-learning, particularly with its popularity in apps. And I'll also show a couple of examples, actually one example of an e-learning app. All right, so what is e-learning? E-learning is the use of electronic media, technology, and information for educational purposes. E-learning can take place in and outside of the classroom. Technology has allowed learning to be more flexible, but when used effectively, e-learning technologies are very beneficial inside the classroom. So just briefly on some past and present mediums of e-learning, cassette and VHS decks, they're relics of classrooms of the past, no longer used anymore, but they were used as audio and visual tools. The CD-ROM. E-learning eventually became more CD-ROM based. CD-ROM computer-based tutorials were equipped with better audio and video. Additionally, the technology promoted a more interactive approach between the user and the software. And then there's the iPad. Particularly mobile and tablet platforms have allowed e-learning to grow exponentially. For example, there's over 75,000 education apps on the App Store alone. Education is the second most popular category in the App Store, number one being games. And 80% of the top-selling paid education apps are targeted towards children, so that's the demographic. Some e-learning app trends. Number one, blended learning. This is basically a combination of offline and online education. For a good example of this is the use of clickers. For example, a professor can choose to enhance his or her lecture by posing a clicker question. It makes the collection of the collection of responses easier for the entire class. The anonymous nature of clickers allows everyone to participate as opposed to just say about 5 or 6 people who are normal participants in a classroom. Also, social and collaborative learning. This basically means that students can communicate with people from outside of classrooms. For example, Skype can be an app used for this method. Also, web-based apps like Google Docs allow people to contribute to a single project and allows everybody to input their strengths accordingly. Finally, there's the gamification of apps, which basically means it's the use of games for learning and problem solving. A good example of this is Duolingo. This is a free language learning app. Duolingo doesn't charge students to learn a new app. What it does is it employs a crowdsourced business model where members of the public are invited to translate content, and vote on translations. The content comes from organizations that pay Duolingo to translate it. Documents can be added to Duolingo for translation with an upload account, and these accounts have to be applied for. Duolingo is available both for Apple and Android platforms. And last year, in 2013, Apple chose Duolingo as its iPhone app of the year. The first time this honor was awarded to an education app. So just quickly on the Duolingo dashboard, basically in every lesson there's about 20 questions, and they deal with translation and pronunciation of the language of your choosing. On the first screen up top on the upper right-hand side, you see the hearts. Those are basically your lives. If you get 5 questions wrong during each lesson, you have to repeat the lesson all over again. In this case, I incorrectly translated "I am eating an orange." I misspelled I provided the wrong conjugation for "un" in "je mange une orange." But in on my next sentence, I was able to translate "I am a child" correctly. Je suis un enfant. And I was able to navigate through the first basic skill lesson. I did complete the second one the other day as well. And Duolingo does allow you to track your progress over time. So thank you. And next is Tim with Audit Apps.
I'm going to talk about audit apps and how they are changing the nature of the audit. So what is an audit app? Essentially, audit apps are tools that use a computerized process to perform an audit procedure that would normally be performed by a clearly overwhelmed human. These apps can be scheduled to run automatically on a periodic basis, whether it be daily, weekly, or monthly, depending on the auditor's needs. So what functions do apps perform, and how are they displayed? The apps will display a quick snapshot of key data on a real-time user interface known as a dashboard. And the dashboard will display data resulting from various analysis methods. So as you can see, the apps can perform a lot of different analytical methods that would normally require hours of extracting and formatting of data on the part of the auditor. So the apps can evaluate trends, they can compute ratios, they can generate statistical summaries, and classify and cluster groups of data. Apps are becoming an integral part of the audit cycle. The specific criteria of an audit plan determines what apps need to be used, and then the apps link the collection of data process with the analysis of the data process. Currently, the burden of requesting data lies on the auditor, which can be a very challenging and time-consuming endeavor. So, but the nature of the automated audit is going to change this. So I know we've all seen this layout in class a few times, but I just want to use it to highlight a few key points. So over there we have the company's data and financial information is extracted into a standardized format known as an audit data standard. And the key here is that these app processes can access that data almost on demand. And that's the key to the whole automated audit, is timely access of data. Here are some examples of audit apps. So if you're performing an audit and you need to analyze accounts receivable to determine if there's any duplicate transactions, there's an app for that. If you need to recalculate depreciation of fixed assets, there's an app for that. If you need to generate a list of transactions that occur at unusual times, there's an app for that as well. So the point is, almost any audit test can be transformed into an app. And this just shows that each app has several different functions that it can perform. So, for instance, accounts payable, it can generate a description of the data that needs to be analyzed. It can show the balances and transactions for each creditor account. It can analyze transactions and detect violations of credit limits. It does aging, duplicate detection, and can determine which users record what transactions. So it does a lot of different functions. Several audit apps have already been developed and are available now. For instance, Caseware has developed over 50 different audit apps, and Idea Marketplace provides an online store where these apps can be purchased. But there's also a lot of potential for the future development of these apps. They're highly interchangeable, and there's a good possibility that you could develop online communities where auditors and developers can collaborate and share different audit app tools, and that way they can create new audit apps to accommodate changing audit needs. So what does this mean for the future of the audit? Well, clearly extracting, pairing, and formatting of data will be automated, which is going to change the nature of the auditor's role. The auditor will now be able to spend more time, they'll be able to use their time more productively and more efficiently by spending more time applying their professional intuition and judgment to cater specifically to a client's audit needs. And also, they'll take on more of an evaluative role in making sure that the monitoring techniques and the tests employed by the apps are appropriate. Additionally, real-time alerts can be provided for suspicious activities as they occur, which is a big step towards the continuous audit. And then lastly, as artificial intelligence expert systems improve, these could potentially be used to create the audit plan, the criteria for the audit plan itself, and then even the rules of these systems can be used to select the actual app that needs to be used in order to perform the plan.
Morning, everyone. Going to be talking about the services provided by electronic banking. These services are provided by banks that are brick and mortar and virtual as well. Diane explained what electronic banking is. Electronic fund transfer is another name for it. These services right here are pretty much general. Majority of the people know about it, so I'm going to quickly go over them. Automated teller machine is a service that's provided to someone that opens a bank account and is given a debit card to go to any ATM and make any transaction or withdraw money, deposit money right there. Even Batman can do that. We have direct deposit, which you give authorization to deposit money into your account, whether it's through an employer or an agency, and it's vice versa. You can make withdrawals as well to make payments such as bills or gym memberships. And then the next one we have is pay by phone system, which is you call your bank and you instruct them how you want to make your payments or how you want to transfer funds. And the next step is debit and credit card purchases. So a debit card is when you make a purchase, it's deducted from your bank account, and a credit card is not deducted from your bank account, but it's deducted from a limit that the bank gives you, and essentially you have to pay that back. And the next one, personal computer and mobile banking, offers you the convenience of doing such transactions in your home or on the go, so you don't have to write down transactions on a ledger like they did back in the days, or you can look back on your statements. And then electronic check conversion is like the machine that you see right there. If the store offers that, you simply go with a blank check, insert it into the machine, and then the machine reads your routing number, your account number, and then that deducts from your bank account right there. So I call these advanced services because maybe for someone who's not tech savvy, especially the older population, these are unfamiliar. So services by e-banking is online customer support. So instead of calling somebody on the phone and punching in these annoying numbers, you simply log on to your account, click on the option to speak with a representative, and you can speak to somebody within a minute or two. Next one is archive of statements. So when you log onto your account as well, you can go to your history, and generally it's about 2 years. You can go check your history account, whether it's your checking account savings or credit card statements. And then another service that just came about within less than a year ago is checking your FICO statement. Like I personally have Discover and Capital One, so I can check my credit score anytime that I want without it negatively affecting me. And the next service that we have right here is online investing. A couple examples right there, Share Builder by Capital One and Bank of America partnering with Merrill Edge, so you can invest and trade stocks and portfolio, the comfort of your home, and you'll also create a retirement account. The next option, it's not necessarily e-banking, but it's an essential tool when it comes to e-banking, is mint.com. As Dan explained earlier, it's pretty much like a snapshot of all your bank accounts. Whatever information that you provide is the information you'll see. And then lastly, we have money sharing apps such as Venmo, Square Cash, and Google Wallet. And how that works is you download the application, you input like your bank account information, your credit card, your debit card, and then you can easily send or receive money to your friends, especially those that conveniently never have cash, so you can just get that money from them. So Google Wallet right there, this is NFC and near-field communication, where you can, like as they shown right there, you go up to register, have your bank information connected to your phone, you tap, and you're ready to go. So service like Google Wallet, it makes banking so much easier, e-banking so much easier that it's makes you wonder, makes you think of a question such as, is it worth being a customer of a bank that's brick and mortar, or is it more convenient being a customer of a virtual bank instead? So with that said, I'm going to let Dave discuss the advantages and disadvantages of being a customer of a virtual bank.
Yeah, just put that down. Nice.
I'm going to go over the pros and cons of virtual banking, but first I'm just going to describe the differences between virtual banking and traditional banking. I don't want to insult anybody's intelligence, but I have to do it. The main differences are traditional banks are like it's a physical structure, it's brick and mortar, you can walk to it, it's down the street. Virtual banking, it's not down the street, it's only online. Virtual banks are starting to bleed over. Traditional banks are starting to get online divisions, and online banks that have traditionally been online are actually starting to have, they're starting to build physical locations as well. I know I'm a member of USAA Bank, and it's big in the military, big for veterans and families. They were traditionally online, and then in 2009 they built their first physical bank, and now they have 16 banks across the country, and they're generally around military bases where they have most of their people. The pros of online banking: online transactions and applications make it easy to do anything you want to do. I know I online bank. Does anybody else here bank online at all? Well, not through Bank of America, through a strictly online bank, maybe like Ally, something like that. We have a couple people. E-banking, strictly online banks offer the same services generally that traditional banks with online departments do. For simple savings accounts, checking accounts, if you want to get a CD, a mortgage, you want to get a loan, you can do all of those things. Their interest rates sometimes can be better because they don't have the overhead, they don't have all the buildings, they don't have all the employees that your regular bank does. That said, don't go out and just get a CD or a savings account at or a mortgage at an online bank just because it's online and it might have a lower or higher rate. Definitely do your research. I know when we were doing research, 2 online banks that generally had pretty good rates were Ally and Everbank, but obviously that's not, it's not across the board. Definitely do your research before you go out and make financial decisions. Investing tools. Online banks are very good at putting information out there. So if you know how to use the tools and you're good with pie charts and whatnot and looking at stock portfolios and whatnot, that's definitely for you. If you don't need to talk to somebody, if you don't need somebody to explain to you how to invest your money, this is definitely something worth looking at because you can go in there and find all the information you want or all the information you need in order to make good decisions with your money. And online banks are very, personal bank accounts, they're very easy to use with other banks. I know with me, I have my online bank linked with, I have a physical bank as well. I bank at TD Bank, so I have those bank accounts linked, and I can do anything I want between those 2 accounts. Cons of virtual banking: there are some downsides. We have online transactions. You might have noticed that was a pro as well. I think it's a pro, but my Nana doesn't think so. My Nana likes to go talk to Susie down at wherever, Valley National or whatever bank. So if you're not technologically savvy or maybe you're paranoid of technology, it's just not for you. I know my Nana specifically, she sends me checks on JFK's birthday and all sorts of things. If she knew that I was cashing those checks with my iPhone, she would go crazy. She wouldn't send me any checks anymore. So some people definitely do like going to talk to Susie to get their loan and deposit their money, things like that. Security, I'm not going to go too much into the risks in security. Joe's going to talk about that, but there are security risks out there. Fees can be a con. Everybody here, I'm assuming, has an ATM card, a debit card. You go to the ATM. You try to go to your bank so you don't get fees, but sometimes, you can't do that. With online banks, a lot of them don't own ATMs everywhere. So they might have a network. They might partner with a bank and have a network somewhere with ATMs in your area, but they might not. So I know my bank, they reimburse me up to $10 every month for fees. I know, I think it was PNC Online. They'll reimburse you for 2 transactions a month. So depending on the bank, you might be getting charged extra fees, depending on the bank. But there are banks out there that will charge you no fees, so it's all finding the right one for you. And cash in hand. I know if I want to go down to Atlantic City and I want to have a lot of money in my pocket when I go down there, I'm not going to be able to do that with my online bank account because I can't take out more than, $4 or $5 or $600, whatever the ATM is going to give me. So I do need to go to TD Bank. I do need to have, I have a little bit of savings in there just in case, so I can have, money if I do need it. So that's kind of a downside to online banking as well. Next up is Joe.
All right. obviously there's a lot of different tactics that people use to infiltrate your bank accounts, but I'm just going to cover two, which are phishing and keyloggers. With phishing, it's the activity of defrauding an online account holder of financial information by posing as a legitimate company. So with banks, legitimate company, the hacker would pose as the bank, and in the email they would send you, they'd try and induce panic by saying someone's accessed your account, or there's the potential for someone to infiltrate your account, and they say that the only way to fix the problem is to provide personal information like your password to your account or credit card numbers. So here's an example of an email you might see. So the person posing as a legitimate company would try and use the same text and logos as your bank to make it as real as possible. And in this case, they would induce panic by saying someone unknown may have access to your account, and that the only way to fix it is to give them personal information. And once they have that, they can access your account and take out money. And the other method I'm going to talk about is keyloggers, which covertly record keystrokes, and they're able to see what you're typing in your computer. So when you go online, you type in your password for your bank account, they'd be able to read it. And here are two methods. The first is hardware, which you can see in the pictures is a physical device put into your computer that records the keystrokes, and that's most prevalent, say, at like your office computer, where like now at home most people have laptops, so there's not as many places to plug in something and not see it. So the newer method is software keylogging, where similar to phishing through an email, they would send you, if you clicked on a link, it would download into your computer, and from there, on the hacker's computer, they can see what you're typing in. All right, so as they mentioned, some of the main things they can do is they try to identify patterns, construct fraud models, and conduct real-time detection, which is some of the stuff we mentioned with the real-time, with auditing, and things like that. And some other things they do is they say that they'll never ask you for your password or PIN when they contact you, so that's your alert right there if someone's trying a phishing scheme into your account. And they use HTTPS as opposed to just HTTP, and the S stands for secure, so it's a secure network. They also use things like two-factor verification, so they want to know something you know and something you have. So a pretty simple example is with your ATMs, you need both your debit card to put in and you need your PIN number. So if someone stole your card, they can't use the ATM without your PIN, and if they know your PIN number, they can't use the ATM without your card. Then they also, the encryption, it will scramble the data so that it can't be read by unauthorized parties when you're interacting with your online bank. And also data integrity, it verifies that the information you send to the bank is not altered during the transfer, and if tampering occurred and it detects it, it'll drop the connection and cancel the transaction. And then lastly, just some simple things that everyone should do is avoid phishing scams. Just be aware when you get emails from people not to open them. Change your passwords on occasion, so in case with a keylogger they got your password. If they don't do anything right away, if changing your password can help. Monitor your account daily, because the sooner you pick up on some fishy activity, you can come to a solution. Don't use public terminals or wireless connections, because it's easier for people to hack into your account from those methods. And have antivirus and spyware up to date, and always log out of your account before exiting the website. So any questions?
Right, as we already know, e-trading is electronic trading, but I want to focus on how this works. Is on the electronic communication networks. Everybody knows NASDAQ, New York Security Exchange, and all the commodity trading platforms. So electronic communication network is a kind of a virtual market. It's not a physical market like you can buy in stock. You're getting a piece of papers of stock that was back in the 19th centuries. This is a completely virtual. Everything is based on the network. The popular ECNs are NYSE, NASDAQ, foreign currency exchange, and CME for the commodity future contract trading. New York Stock Exchange. As we already know, New York Stock Exchange is based in New York City, and we also call it Big Board. Currently, there are about 2,800 companies that with a global market capitalization about 18 trillion traded on New York Stock Exchange. Today, more than half of all New York Stock Exchange trade are conducted electronically. What are the stuff that you can trade actually on New York Stock Exchange? Of course, the most liquid stuff are the stocks. And then there are also options and bonds. But I want to focus something that really recently created more and being traded more. It's called the exchange trade product. The most favorite part is the exchange trade funds. It's called ETFs. A lot of people heard about that, but probably won't know what that term's for. It's actually more like a mutual funds. It's not particular a stock. Could be a basket of a whole bunch of different kind of stock put together, and it can also be an index put it in together. It's like a big pool. NYSE RCAR is a U.S. leader for EFT trading with over 1,000 primary ETF listings. ETFs are effectively mutual funds that trade like stock, but unlike stocks, where price discovery is a function of supply and demand throughout the trading days. Most ETFs tracks an index, such as stock index or bond index. ETFs' associated costs are quite low, and portfolios are flexible and tax efficient. So that's why people prefer to trade more and more on the more and more ETFs. So those are just the example of on ETFs. NASDAQ. NASDAQ is complete 100% electronic trading, platform. So NASDAQ began trading on February 8, 1971. It was the world's first electronic stock market. The exchange platform is actually owned by NASDAQ OMX Group, which is also known as the OMX stock market. There are also the similar stuff that you can trade on the NASDAQ. Some of the very popular stocks that we already know, like Apple's, Google, Microsoft, Oracle's, Amazon's, Intel, Amgen, which is the biggest pharmaceutical company. Of course, you can also trade on commodities, benchmark index for the U.S. technology stocks such as the S&P 500, Russell 1000, 2000, 3000. And this is an example of the NASDAQ most active stocks. CME Group. It actually stands for the Chicago Mercantile Exchange. It's one of the largest option and future exchange market. It owns and operates large derivative and future exchange in Chicago and also in New York City, as well as online trading platforms. Currency exchange trading. The first ECN for internet currency trading was New York-based Matchbook FX, founded in 1999. Today, FX ECN like Current, Next, Bloomberg, TradeBooks, those are the popular platforms that people use to trade foreign currencies. And this is how it looks on the Current Next. Those are the popular brokers, as we already know, like StockTrade, Scottrade, Fidelity, and Swap.
We're
talking about impact of trading, e-trading specifically. First, some good things. The big thing here is increased liquidity, lower cost of transactions, but some of the negatives we'll talk about later are high-frequency trading, ultra-high-frequency trading, and front-running is something that we eliminate, but we get back. So liquidity, lower costs. Institutional investors in particular have direct access to markets more easily now. If you're a retail investor, you're still going to have to go through a brokerage, but because of the automated process, it's a lot cheaper and people do a lot more trades, even though retail investing is still paled in comparison to the volume of institutional. We have a little bit better transparency because you can see right on your computer screen. You don't have to call a broker. Faster execution and confirmation, so you know exactly what traded at what price and when. And this is just a little bit of a idea of the difference of liquidity. That's old-time stock market. You were limited by how many people could fit on the exchange floor, and now we have basically whoever wants to can trade from home. You have offices that you can trade remotely from the stock exchange, and you have things like Eurex, which is a completely online platform that investors do have direct access to, even at the retail level. This shows the 90s were a big time of increased electronic trading and more people adopting it. You can see what happened to the volume over the decade, and it's increased more since then. Using the electronic communication networks, you no longer depend on market makers and the brokerage houses. Whereas in the past, brokerage houses would try to match trades internally to their best customers at the best prices, and the lower-end customers can take what they can get. Now you have a lot more access to see what you should be getting, and that doesn't happen as much anymore. And this is a little chart showing what happens when they announced electronic trading would be coming to markets. And now we'll talk about some of the bad things. According to these 6 measures, after online trading, the price and premium of stocks generally goes down. We'll focus on dividends plus capital gains. You can see just solo fuller trading versus electronic trading, the premium's a lot less. And again, here, the volatility, so the bouncing up and down, the noise on the stock price is a lot less because you have much better information that you're going on. We'll talk a little bit about algorithmic trading. This is just a definition. It accounted for 73% of U.S. trading volume in 2011, so it's a really big part of trading. And it uses any kind of sophisticated mathematical algorithm. High frequency is limited by the length of time that your strategy is employed. You're holding it for seconds or milliseconds. Ultra high frequency, you're holding it even less time, obviously. And that contributed to the May 6, 2010 crash, flash crash, 9%, losing $600 billion in market value in a fraction of a second. This is a model of an algorithm, and it's a learning algorithm. So you have your inputs, your signals, it executes the trades, and then it feeds back real-time data. Little diagram of the flash crash. This was the Dow on May 6th, and you can see it went from here all the way down. And it only stayed there for a second, so if you happen to be watching the market, good for you. Flash Boys was a book that came out by Michael Lewis, and it illustrated a lot about ultra-high frequency trading and the issues with it. And people are basically just putting in an algorithm that front runs trades, so they know what people are buying, they buy it, and then they sell it to those people. So they're capitalizing a cent, fraction of a cent, but every millisecond with every trade virtually. So they're able to siphon away billions of dollars, but people don't always notice because it's such a small amount. Matt's going to talk to you about future.
How many people here follow stocks daily, weekly basis? How many people here buy stocks,
past 6 months, past year. Sell stocks past 6 months, past year. All right, long-term guys here. So I was trying to talk about, I want to talk about the future of trading, and I didn't want to speculate about what that might entail. I wanted to base it on what we knew about the past and what we know about the present, and try to make an estimate, a guess about what could happen in the future. So I'm going to kind of go off of what Dan started to talk about with high-frequency trades. There's a lot of bubbles and crashes. This is just a really small snapshot of things that have happened in the past. I guess I'm going to just throw it out there that I'm going to predict that unless high-frequency trading is regulated a bit more, that it could lead to problems. And these are the reforms that some of these things led to. I won't go over them all, but you can see here. The crashes always take people by surprise. We try to learn from our mistakes and prevent them from happening again. I think that the SEC is beginning to, obviously more than beginning, to realize this about high-frequency trading. The pros, it's very controversial. I was happy when I read something that because the market has changed so much in the past decade, even experienced and seasoned traders and investors find it really difficult and don't totally understand the market. It's very complex. Pros, high-frequency trading and traders, they add liquidity to the market and decrease volatility. Cons, it's systemically unfair and exploitable, and actually, in opposition, it increases volatility. So there's a debate. It depends who you ask. And I think what I've learned in researching financial things is there's not a lot of objectivity in finance. A lot of subjective. There's a lot of money on the line, and people have their interests that they're protecting. So front running, is it real or not real? It's illegal, I believe. And are people... Is it happening, basically? Some people say yes, some people say no. Depends who you ask, and I think you could imagine. The high-frequency traders are probably saying no. Basically, they're finding out what large companies or large groups of trades are happening and getting ahead of them in anticipation of that trade going through and capitalizing on that by doing their own trade. Dark pools, good or bad, it's kind of hiding things and not impacting the market as much. There's dark pools, gray pools, lit pools. Fair or not fair? I think that it's abusable, high-frequency trades. The SEC needs to step in. Here are some things that the SEC is doing. They're working with a company in New Jersey in Red Bank, TradeWorks, to develop a program. They've done this already. I'll jump down. The Consolidated Audit Trail is a $1 billion project that the contract for which has not been awarded yet, and it will be. And it will. The SEC will then be able to look into dark pools and other trades that they're not. They don't have a whole look on the market. They don't have a whole view of the market yet. Anyway.
Good morning, guys. My group will be talking about cloud computing today. Many of you have used cloud computing, but you just didn't realize you were using it. I'm going to start with the introduction and the history. Tina will talk about software as a service. Yusuke will talk about platform as a service. John Lee will talk about infrastructure as a service. And Wilson will talk about the future of cloud computing. So what is cloud computing? Everyone in this room has used cloud computing. You just didn't realize that you were using it. It's basically any resource that is retrieved through a web-based tool. So storing and accessing program through the internet instead of your hard drive. For example, Google Drive, if you have iCloud, or Gmail is considered cloud computing. So some of the major events in cloud computing started back in the 1950s. With mainframe computers. It basically allowed dumb terminals to access one main terminal. So that was the basic of cloud computing. In the 70s, the virtual machines started to arrive. They're basically operating system within operating system, kind of operating system inception. And in 1999, one of the major events was Salesforce. Salesforce did a lot of outsourcing for many business essential tools such as marketing, accounting, human resource management. In 2002, Amazon Web Service came out with their infrastructure as a service and also platform as a service. And they're one of the main provider of cloud computing. And in 2009, Google introduced Google Apps. These are more consumer-friendly. Amazon was getting towards the big companies, but Google was trying to get all the regular people to use cloud computing, such as Gmails and Google Docs and Google Sheets. And so with that background in the history, we can talk about the evolution of cloud computing. In the beginning, there was grid computing, where basically just parallel computing, solving programs. And then there was utility computing, which basically says we can sell computing resources as a service instead of just the hardware itself to companies. And then there's software as a service computing, where companies such as Salesforce is providing the software and other company can rent the service and they can pay the amount that they use instead of buying the software, building their own software. And this leads to what is now considered as cloud computing, with the combination of platform as a service, infrastructure as a service, and software as a service. So before cloud computing, when you're doing a group project, what you need to do is call a meeting, have everybody meet up, do the project in a very time-constrained manner. And then the meeting is done. You have to plan a second meeting to figure out what are you going to do next, and it's just a hassle. And so the next step was with technology, but without cloud computing. And what that involved is people emailing each other. Imagine having one document and you have 5 people working on it. So you send it, one person send it to 4 people, there's 4 versions of the same document, people start editing it, they start sending it back to you. Now you got like 14 versions of the documents, and then people send it back to you. And there's just so many versions, and the one guy that has to put it all together is going to have a really, really bad night. And so now, with cloud computing, it is so much easier, and you've all used this. There's Google Docs, Google Sheets, and Google Slide. So instead of sending emails together, you can say everybody access this one document, and you can all edit it. You can make changes. You can write comments. You can do everything in one master file, and that makes everyone happy. As the saying goes, happy coworker leads to happy workplaces. And so some of the last slide is about the advantages and disadvantages of cloud computing. It's cost efficient. This is more towards companies. It's cost efficient because they don't have to buy the infrastructure. It's scalable, so the more you need, the more you purchase the service. It's quickly deployed. You don't have to install anything. All the software is prepared for you. It's environmentally friendly. You don't waste electricity in your company because everything is done outside. It's convenient, and it increases work efficiency, as the example I was given before. Some of these disadvantages include security, downtime, dependency, increased vulnerability, limited control, and flexibility. The one big issue is downtime. Not only is your internet, if your internet is affected, you can't use the software. If the vendor internet is affected, you can't use the software. And the dependency and vendor lock-in is also important because if you're using an accounting tool provided by one cloud company and you want to use a different one, it takes a lot of effort and a lot of time to transit to the other company. And next we have Tina with software as a service.
Cloud computing providers provide these 3 models, SaaS, PaaS, and IaaS. Their relationship kind of like this, what they showed in these pictures. First, you need to have the infrastructure first, and then the application developers develop the platforms. And at last, you have the software for your end users. I'll start with the top one, the easiest one. SaaS is software as a service, which means that the cloud providers just provide the operate application software in the cloud, and the users just access to the software from the cloud clients. And it is also on-demand software, which means you actually pay when you use them, and it is paid by per use basis. At the end, the target users for the SaaS is end users like us or like business users. I'll use a really simple example to explain what is SaaS and what is cloud computing. You used to use email by download in your laptop or storage in your laptop. Now you don't use them except this, you use Gmail or Yahoo Mail, which is in the cloud. That means that your emails is stored at a connection service, and what you need is just get into this connection, and you can view your emails. Of course, the SaaS goes a more complicated way. Here is like the solution chain of SaaS. You can see like this is the data center of the company. They have different database inside. And as an employee, you could just log in to find what information you need and to upload the data. For the customers, if I want to view the company's report, what I need is to get in the browsers by any of the devices. I just mentioned some of the benefits. Let's summarize them. Except the words, and I just gave you some pictures. The first one is, it is more safe. If your computer is stolen or your hard drive is broken, you could still get your information, important information. The second one is reduce the cost. You used to buy the Microsoft Office by $500, and now you could have another choice is to pay $29 per month, which is more flexible, and you could stop whenever you want because this is on-demand software. The third one is you could automatically upload, and you could use wherever and whatever you like. This is most examples about software as a service. Like I just mentioned, Gmail is simplest one, and Workday and Salesforce. I'll use the NetSuite as an example. This is the website for the NetSuite. You can see that more than like 20,000 companies all over the world are now using their database. They help the companies to manage their core business process by using one simple, fully integrated system, including their ERP, CRM, and e-commerce, financial, and other kind of things. Now I'll end my part, and Yusuke will share more about SaaS.
So I'm going to talk about PaaS, Platform as a Service. And I'm going to talk about 4 things today. What is PaaS in cloud computing? Features, benefits of PaaS to application developers, and some concerns. And it stands for Platform as a Service, as I said, and is a category of cloud computing that provides platform and environment for developers to build applications and services over the internet, and it's easily accessible via web browser. And consumer doesn't manage the underlying cloud infrastructure, including networks, servers, operating systems, or storage. And it's an outgrowth of software as a service, or SaaS, which Tina just talked about. Also, as with most cloud offerings, PaaS services are generally paid for on a subscription basis with clients paying just for what they use, and the infrastructure and applications are managed for customers. And also support is available. And services are constantly updated with existing services upgraded and new features added. And this is the list of features. I think it's easier to understand PaaS as operating system because you need this system in order to learn software. And others are server-side scripting environment, database management system, server software support, storage, network access, tools for design development, hosting. And these are some of the biggest providers. None touched on Salesforce.com, and Amazon Web Services are famous, Google App Engine. And if you go to the website of Engine Yard, you can see the video showing what PaaS is. And it's very easy to understand. It's like 2 minutes video. And now, benefits of PaaS to developers. So there are 6 benefits. First, they don't have to invest in physical infrastructure. And I think this is the main reason to use this service. Being able to rent virtual infrastructure has both cost benefits and practical benefits. They don't need to purchase hardware themselves or employ the expertise to manage it. So clients will only need to rent the sources when needed. And second, makes development possible for non-experts. With PaaS offerings, anyone can develop an application. They can simply do this through their web browser. And third, flexibility. Consumers can have control over the tools that are installed within their platforms and can create a platform that suits their specific requirements. They can pick and choose the features they feel necessary. Fourth, adaptability. Features can be changed when needed. Fifth, teams in various locations can work together. So as an internet connection and web browser are all that is required, developers spread across several locations can work together on the same application build. And lastly, security is provided, including data security and backup and recovery. And these are just a few concerns. If you subscribe to a PaaS vendor, you will be limited to using IaaS and SaaS products that are compatible with the platform as a service you choose. It's like using a software, and you have to think about compatibility between Mac and Windows OS. I think it's easy to understand that way. And the current PaaS market presents a challenge because it is still quite young and highly fragmented, with each cloud provider promoting its own incompatible standards. And this is the global market share as of March 2014, and current global PaaS market overall value is $9.3 billion. As you can see, North America has more than half of the global market share, and others are Europe, Southeast Asia, and Asia Pacific, Japan, Middle East, and Africa, South America. And now, Jack is going to talk about IaaS.
So the IaaS stands for the infrastructure as a service, and the definition of infrastructure as a service is pretty simple. You run cloud infrastructure such as servers, storage, and networking on demand in a pay-as-you-go model. So since you don't need to invest in your own hardware, the infrastructure as a service is perfect for startups or businesses testing out a new idea. And what is more, since the infrastructure scales on demand, it is great for workloads that fluctuated rapidly. So imagine you run the infrastructure from the cloud provider and access that infrastructure over the internet in order to create or use applications. The service provider will handle the networking, servers, storage, and virtualization. The things you need to do is to manage your data, runtime, and so on. So here are some IaaS providers: the Amazon Web Service, the SunGrid, SkyTab, and GoGrid. So the EC2, which stands for the Elastic Compute Cloud provided by Amazon, allows users to rent virtual computers and run their own computer application on it. For example, the New York Times uses hundreds of Amazon EC2 instances to deal with the 4 TB PDF documents in 24 hours. And we cannot imagine how much it will cost if we buy 100 PC servers to do this job. So let's see the benefits which the infrastructure as a service can bring to us. Imagine we build a building on our own. I mean, we do it by ourselves. We need to consider a lot of factors, such as how to buy the land, design the blueprints, buy materials, build the buildings, and take care of the facilities and management. However, when we try to rent the building, we don't need to think more about these factors. The same method was used in the IT infrastructure in-house. When we do it in-house, we need to buy a lot of hardware room, servers, networking, facilities, and do a lot of management. However, with the help of the IaaS providers, we don't need to do these things. So here are the steps when we try to set up an application in the IaaS environment. So we need to choose image and then create the virtual machines from the database management system and configure the DBMS. And then we choose image, create and configure the VMs for the application. The next step is to provision the database, then create tables and data, install application, configure a load balancer, and manage VMs and DBMS. So the next is Wilson. He's going to talk about the future of cloud computing.
All right, good morning, everyone. So I'm going to cover the future of cloud computing. All right, so just a general outline. I'm going to go over the predictions, the barriers to growth, and the 2014 Future of Cloud Computing survey results. All right, these predictions were actually made by the executive director of cloud computing for IBM. He predicted that there's going to be increased application availability on cloud. He predicted that by 2016, over a quarter of all applications will be available on cloud, and that's going to be due to because a lot of the applications that are being developed now are developed right from the start for cloud. There's going to be increased market growth for cloud. Using research from Gartner. Gartner is like it's a big information technology research and advisory firm, and they predicted that for 2011 and 2017, cloud will be a $250 billion market. And they also predicted that the software as a service market will grow at a yearly growth rate of 20.2%. So by 2017, it's going to be a $45.6 billion market, as compared to $18.2 billion in 2012. Next, there's going to be increased hybrid cloud adoption. Gartner also proposes that 50% of enterprises will have hybrid clouds by 2017. Hybrid clouds, I don't think it was mentioned, but it's pretty much just a mixture of, it's a combination of different clouds, like public and private clouds combined. And then more and more CIOs are going to be incorporating cloud in their future business strategies. Next, for increased development, like I said before, with 85% of the new software being developed for cloud, Evans Data Corporation, which is another information research and advisory firm, they predict that more and more developers will begin working on cloud, and with that said, there's going to come increased innovation. All right, so Nong mentioned before security and privacy concerns. It was cited by 49% of the respondents in the 2014 Future of Cloud Computing survey as a concern. And in a recent Tech Times article, the author mentioned that if security and privacy concerns aren't addressed, that cloud will eventually fail and it won't be adopted by corporations and people in general. Rajat Borgava, he's the co-founder of a company called JumpCloud. It's a cloud security startup. He was quoted for saying, "When you don't own the network, it's open to the rest of the world, and you don't control the layers of the stack, the cloud by definition is more insecure than storing data on premises." All right, before I get into the survey, this is a quote from Mike Schutz. He's the general manager for cloud platform marketing for Microsoft. He says, "What comes across to me loud and clear from this survey as in referring to the 2014 Future of Cloud Computing survey, is that even more businesses are no longer thinking why cloud, but will focus the next 12 to 24 months figuring out how do I execute a long-term cloud strategy." All right, so the survey, just a little background. It's in the fourth annual survey. It had 72 collaborators and 1,358 responders. It's a really huge increase from the previous surveys that were held. The survey was actually compiled all the results into a 124-slide PowerPoint presentation. Obviously, I'm not going to go over all 124 slides, so I'm just going to give you guys like key survey findings. For example, 45% want to or already run their company in cloud. 65 to 70% of respondents will move to cloud processing in the next 12 to 24 months. Software as a service has moved to third in CIO priorities from fifth place. And just in case you guys don't know, CIO just means like Chief Information Officer. It's just like the head guy for information technology in corporations. 27% of respondents believe using cloud platform service will help lower capital expenses. And approximately 66% of data is in cloud today, and it's predicted to grow to 73% in 2 years. And then by 2017, nearly 2/3 of all workloads will be processed in cloud data centers. And these are some of the collaborators and companies that showed up to the survey. Some key companies to mention are Microsoft, Amazon Web Services, I believe Oracle was there. And here's our sources.
Hi, everyone. We're here to talk to you today about modern technology in the developing world. So we're going to have a little different take on everything we've been talking about. We're going to talk about how technology is reshaping the way individuals and communities in the developing world manage their finances, earn a living, and basically how their lives have improved with this technology. So I'm going to be talking about cell phones. Difan's going to be talking about donating platforms. Peihuan is going to be talking about some medical advances. Jaehui is going to be talking about manufacturing, and Shin is going to be talking about agricultural technology. So while we're doing this presentation, I want you guys to keep in mind about whether you think that this is all this technology, if it's really helping the entire world, not just the developed world. And this is just some, the way technology is being used. So what I want to do is I want to talk to you about Somaliland. And commercial banking disappeared there in the early 1990s, so there are basically no banks there. And there is Western Union, but there's not a lot of these throughout the country. So what do people do for money? Because most of the country relies on remittances from family members, and they have no way of getting the money. So what are they using? They're using this program called ZAD and their cell phones. So basically the way this works is, let's say I want to send money to someone, one of my family members in Somaliland. I basically log onto this website, put in their phone number, and donate money to them. I can send it to them in whatever currency I want to send it to, and there's a fixed exchange rate and all of that. They'll automatically get the money, and they'll have it on their cell phone. If they want to take out cash, they'll be able to go to one of the kiosks and take out cash. It's basically just like normal banking.
Does it have to be a smartphone?
No. They don't have, for the most part, they don't have smartphones. They have, the old phones. Yeah. So how they use this once they receive the money is they have to put in a 4-digit code, and most vendors, when you go out on the street, they have their 3-digit code outside. So if you want to buy something from them, you could just see the 3-digit code in front of their store, and you automatically send them the money and walk away with whatever product you have. They also mentioned that a lot of this is being used, like when they trade cows and all of this. So you basically want to go buy a new cow. You go to the merchant, put in his code, and now you have a cow. Another thing I wanted to mention was the Grameen Village Phone. So what this basically is they're basically aiming this towards women. They do background checks on certain women, their credit history, they check references and all of that, and they're allowing them to start these new businesses. So what these businesses are they're small stands where they have, let's say, 10 cell phones, and people can come and basically rent a cell phone, or so it would be something like a payphone. You give them a certain amount of money and you can use the phones to call. The thing with this is that a lot of people can't afford cell phones, so this is what they're using to communicate with their family members. So this is another way that's helping I guess stay in the loop. Overall, mobile devices in regions like Africa are largely limited to voice and short message service texting. Like you asked about the smartphones. It's usually not the smartphones. It's like the older phones that we had. But even the most basic mobile communications can increase school attendance, facilitate banking or cash transfers. Like I mentioned to you, it's also creating jobs and advancing, women in certain countries. They are now their own business owners, so it's helping developing countries in that way. It measures health indicators, accelerates disaster response, and fuels citizen engagement in governance and democracy.
Today I'm going to talk about how information technology changes manufacturing in the developing world. And we can see this picture, there's a young female worker trying to finish her task, and we can also see the materials piled up in front of her desk, and she was trying to complete the work, but usually in developing countries it may take 14 hours a day for a worker to finish his task, and it's quite boring and tedious to work in the production line, and sometimes it not only do damages to people's health, but sometimes even cause psychological problems to these young workers. And maybe you can remember this famous from movie The Modern Times. The worker Charlie Chaplin displayed went crazy after in the production line for several hours, and you can perhaps you can remember this picture as well. And do you remember that the worker Charlie Chaplin plays in the movie? He went down the street and tried to attack the woman because the button on the woman's clothes really looks like the nails in the production line, and the police just arrest him and send him to jail. And not only the workers in the developing world are faced with tedious work and heavy manual work, and they are also sometimes faced with danger. We can see these workers in the picture trying to move those tanks filled with chemical waste. It can be quite dangerous because being exposed to a toxic gas and sometimes chemical materials can do damage to one's health, and sometimes accident happens and explosion may cause hundreds of lives. But why would that happen? Because that time information technology wasn't there to help them, and now things have changed. We can see this picture, and in this picture there's a painting robot, and actually helping human workers to finish the painting work. And here is the definition of industrial robot, and I would like to discuss most widely used type of industrial robot, and that is robot arm. It helps to improve the efficiency. It helps to free workers from heavy manual tedious works, and it's more accurate than human workers because, it's programmable. Even the most skilled workers cannot be compared with a robot arm, and it's also helped to free workers from danger. And sometimes, in industries, you don't need a whole robot to finish the work. Only a robot arm that can function like a human hand will be okay. And this example of a robot arm helping to do the lifting work in the factory, so workers in developing world now are not faced with heavy manual work. And this example of automatic production line actually is a picture of a chemical factories with this automatic production line. Workers can sit far away in a safe place and use these machines to do the manufacturing work for them. And to summarize what information technology has bring to developing world, and I came up with 4 points: better efficiency, free workers from heavy manual tedious manufacturing work, and 3 is better product quality, and 4 is less danger accident.
Okay, so today we're going to talk to you guys about neuromorphic chips, and they could be the chips that power the technology of the future and the technology that we're talking about. So it's really interesting and really relevant to what we've been discussing so far. So I'm going to start off with an introduction. Kevin's going to talk about current projects. Yaron's going to talk about the Human Brain Project, and Rich is going to talk about future uses. So what are they? So they're microprocessors configured more like brains than traditional computer chips, and they attempt to model in silicon how neurons and synapses interact in the brain. And so basically, these companies are making chips with digital neurons in the chips and also making synapses to establish connections between the neurons. And basically, neurons remember recent activities, and synapses remember the neurons they're associated with. So this is how you learn. So when a neuron interacts with a synapse, there's a spike of energy. The more that happens, the more that a connection forms between the neuron and the synapse, and that's how you learn. So they're trying to replicate that in a chip. So, for example, IBM makes chips that have 256 digital neurons, 262,000 programmable synapses, and 65,000 learning synapses. So they're hoping that it's going to work like the brain does. But the brain has millions and billions of neurons and synapses. So obviously it's on a much lower scale. But because it uses the spiking energy or the pulsing energy, it hopefully will use less energy than traditional computer chips that use a constant flow of energy. So how do they work? So usually they put the chip in some sort of a robot or a computer that has a camera on it that can detect images. So they work the best with visual or auditory stimuli. So they would input some sort of an object or a photo or a sound, and then they need some sort of feedback. So say there's a picture of a dog and they say this is good or this is bad. From then on, they use pre-processing and selective attention to decide that all dogs are good or all dogs are bad. And they don't need to be programmed to make that connection, which is huge because computers have to be programmed to make those connections now. So these are what the chips look like right now. I'm not a scientist, so I can't exactly go into detail about what's going on here, and the chips are still, they're in their very early stages, but this is just so you know what they look like. So typical computers use the von Neumann architecture, which means that they're fast number crunchers and information manipulators, and they work on if X, then do Y. But because computers in the future need to process vast amounts of big data and act in real time and adjust and deal with ambiguity, these chips are hopefully going to help computers be able to do that. So neuromorphic chips are good at detecting and predicting patterns in complex data using relatively little energy. And they're good for applications that are rich in visual or auditory data that require a machine to adjust its behavior as it interacts with the world. And just to get you guys kind of thinking, just think about how these could be used with continuous auditing or apps and financial information. So there's a lot that can be done with them. Versus traditional chips, which can basically reliably make calculations, and they're good at anything that can be reduced to a numerical problem. So this is just one of the current projects. A company called Qualcomm is one of the lead companies in the U.S. working on this, and it's called the Zeroth program. So just to kind of set up, they did this at their company, and it's not videotaped. I'm going to show you a separate video, but basically there's a little robot called Pioneer, and it's in a room filled with a bunch of toys, and there are 3 bins, and an engineer would look at the little robot and go like this. So it was standing by a Captain America little toy. It went like this. And so the robot knew to pick up the toy and put it in the bin. And then automatically it came back out of all the toys and picked up a Spider-Man and put it in the bin. So it didn't have to be told that they were connected. It made that connection on its own. And basically it's learning by what the engineers are telling it. You can look back at the other chart that kind of explained how they worked, but that also explains this. But it's really cool that it's working like how a brain would work, obviously on a lower scale. So this is a video just showing. Oh. Uh-oh. Okay, all right. I'm not going to waste time showing the video. Sorry, guys. But basically what the video shows is a small robot that's in a room, and there's a bunch of colored tiles on the floor. And if it goes over a white tile and they say that that's good, it only moves on the white tiles. Or if it says to avoid it, it avoids it. So it's really cool to see that the robot is learning and it's not being programmed. So this is really pretty amazing. So now Kevin's going to talk about more current projects.
So the Synapse project by IBM is pretty cool. It's a scalable, interconnected, configurable network of neurosynaptic cores like Karim was talking about. And they use neurosynaptic chips to allow for computing systems that more closely emulate the brain's computing efficiency, size, and power usage. So like she was saying, it can kind of make associations and kind of like learn without being necessarily told specifically like how to function or what to process. This is, I think, a pretty good picture of how people kind of come up with the ideas for chips. So we have the Blue Brain project, and it uses, this is a team in Switzerland, the Brain and Mind Institute, that came together in 2005 with the goal to reverse engineer the brain from the molecular level. Their kind of one of their things was to learn more about consciousness. And so in 2005, by the end of their first year, they had completed the first cellular model. And then 3 years later, in 2008, they completed the first cellular column, which consisted of 10,000 cells. And then in 2011, they did the first mesocircuit, which is 100 columns or 1 million cells. In 2014, they had planned, I didn't find updated information about whether they had gotten this far, but they wanted to have successfully synthesized a artificial rat brain by using 100 mesocircuits, which is 100 million cells. And by 2023, they plan to create the first artificial human brain, at least in size and capacity, which by using 100,000 mesocircuits. So that's quite a big accomplishment and goal, I think. And so this is so on the left there, you can kind of see the different systems, and then on the right, you can kind of see a closer view of how the systems are put together. All right, so then another team is working on this thing called the Neurogrid, and it was started in 2009 by Stanford University. And this was the team that kind of developed the neural pulse system, which Corinne was talking about, where instead of just kind of using a constant flow of energy, it kind of uses pulses of energy to activate different cells and processes. And since its creation, it's been mainly used for simulation experiments, but we still have like a long way to go with the energy use. Just to kind of give you, just to kind of put this in perspective, the NeuroGrid uses about 1,250,000 neurons, whereas the human brain has about 100 billion neurons, and so with the NeuroGrid, it uses about 3 times the amount of energy as the human brain does currently, so we still have quite a ways to go before that matches up. All right, and so now Yaron is going to be talking about the Human Brain Project.
Okay. The objective of the Human Brain Project is to construct a simulation of the human brain using neuromorphic chips. And it is a synergy between biology and information computing technology. Now, just a few facts. It's a 10-year project established in 2013. It is funded by the European Union, and Germany is actually the major funder. They're funding 23% of this project. Cost 1.19 billion euros, which is $1.6 billion. And it has 87 partners which are working together in this project. Now, the differences. There is a huge difference between traditional computing and neuromorphic computing. And the Human Brain Project is using this platform, the neuromorphic computing platform. Now, the traditional thinking is, if you want to reach, more advanced artificial intelligence, you look at it from the perspective of the algorithm and how to best model brain behavior using the algorithm to build that model of the brain. Now, with neuromorphic computing, it's a different approach. It's a bottom-up approach where you look at the deep mechanics of the brain, and from that, you can build a better model. You could use this using the neuromorphic computing technology. Now, it's both a bottom-up approach and a top-down, because it also uses the cognition, so basic processes of cognition. So it's a bottom-up approach and a top-down approach. Now, I'll go next. Yes. Now, there are a few applications of the Human Brain Project. One of them is neuroscience, where you're able to bridge the gap between biology and cognition. So it's basically between cells and genes and behavior and cognition. So it really is able to map and connect the two. Now, you're able to create these manipulations which you weren't able to do in the past, where, you can't, cut a human brain, a live human brain, and here you have such a detailed model that you can really dig in and learn a lot about the human brain without ethical dilemmas. So data integration, the idea of the Human Brain Project is to collect vast amounts of data. So once you have, for instance, a situation where you have missing information, you can predict what that missing information is based on that vast amount of data. Second application of the Human Brain Project is in the medical field, and there are short-term and long-term goals. So in the short term, they're looking for the biological signature of disease. So by collecting vast amounts of data from hospitals and using a decentralized approach where they're not actually collecting at a centralized location, they're gathering vast amounts of data, and they can find early diagnoses for degenerative diseases, neurological and psychiatric. So diseases such as Alzheimer's or schizophrenia, they can find, they can really find it early on and create personalized medicine. Now, the long-term goal is once they have that established, once they really studied the brain in more detail and they gathered enough information, they can create a disease simulation and identify the root cause. Now, there's been a lot of criticism of the project by about 250 neuroscientists. And there are a few arguments. So one is the feasibility. They're saying, is this something that we could do now? Is this something we could do? I feel that a lot of these neuroscientists are sort of afraid of losing their jobs, and they resist because of that. They don't want to, it's uncertainty. Narrow focus. They're concerned that that this project is basically, it wants to just map the brain in a very superficial way. And they think that money will be diverted from other areas of neuroscientific research. And also, this is a long-term project, so, some people, in neuroscience, you do want to have some data in the shorter term, and it will divert funds from that. Now, they also have a concern about the fact that it's a top-down approach rather than collaborative. It's not as collaborative as they want to, and it is the exorbitant cost. We were talking about over €1 billion, so that's a significant amount of money. Now, there has been some talk about collaboration with the American program, the Brain Initiative. So that would definitely reap benefits, and it would really create. Okay. Now, Rich is going to talk about future uses.
All right, guys. So there's a whole laundry list of possibilities that we could talk about. We picked a few that we thought were the most interesting. Starting with smartphones. Qualcomm wants to have their Zeroth chip commercialized as soon as next year. So what does that mean for your smartphone? Well, they want it to be your cognitive companion, and they described it as having a digital sixth sense. Now, that doesn't mean your phone is going to see dead people like Bruce Willis. It just means that your phone is going to be more in tune with you, and it'll better anticipate your needs. So if you take a picture of somebody, it'll automatically tag them in every subsequent photo without you telling it to. If you normally get up at a certain time, it'll automatically set an alarm for that time every single day. And the idea is for it to just do it on its own without you having to program it to do that. Because while computers that we have right now, they're good at linear functions and stuff like that, these neuromorphic chips are much better at like image processing and sensing and understanding people and stuff like that. For drones, the Synapse project that Kevin was talking about, they are working with HRL Laboratories out in California. And what they want to do by the end of the year is put a neuromorphic chip in a small bird-sized drone, and they're going to fly it around a couple of rooms, and they're going to see what it picks up on, how well it remembers things, and how it uses that information to navigate on its own. And the idea behind that comes from the project's hub, Narayan Srinivasa. I hope I said that right. He claims that his neuromorphic chip doesn't require a single line of programming. So we'll see how true that is in the coming months. Tumbleweed, one example of, it's an autonomous robot that we just found interesting. It uses multi-model sensing, and its main use is search and rescue. It's deployed in a disaster area. It surveys the surrounding environment, and it identifies people in need, and it'll communicate with them using audio and video, and it'll guide them to safety. Assistive vision, I know other groups have talked about wearables. I'm just going to talk about this really briefly. Low-powered, lightweight eyeglasses designed to help the visually impaired. If you're completely blind, it uses enhanced auditory sensors. If you're partially blind, it uses enhanced video. So you can recognize objects and obstacles, and it'll help the user navigate through the area. The conversation flower. You put it on the table in your meeting or wherever you are, and it automatically identifies who's talking and creates a digital transcript. The cool thing about this one, as the conversation becomes more lively and more interesting, the flower opens up. So if you're talking and that flower starts to close, that means you're putting the whole room to sleep. Jellyfish. It uses a network of sensors. It's thrown straight into the water, and it does stuff. It can predict or help predict tsunamis. It can monitor shipping lanes for safety and environmental protection. It is solar powered, and it monitors the environment and reports hazards. Watson. For those of you who watch Jeopardy, the Watson computer was the one that just beat everybody. The Watson computer focuses on language and analytical thinking. Its cognitive chips are more capable in conjunction with sensors and pattern recognition. And the cool thing about Watson is that it wasn't hooked up to the internet. It got all of its information straight from a database. So, well, you've got, everyone here's got their left brain and they got their right brain. Watson is more the left brain, while neuromorphic chips are considered to be the right brain. So you put those two together, and you could have some pretty endless possibilities there. So what does this mean for auditing and accounting? Well, we could have neuromorphic chips could help us create continuous auditing apps that don't have to be programmed. As we just talked about, it could give you improved wearables and smarter smartphones. So